4. Surface areas and volumes of cones. Can I find the surface area, volume of cones? Can I find the volumes of similar cones? And can I find the volumes of composite solids? The lateral area of a cone. The lateral area is this part that goes around, and if you pull it apart, it's actually a sector. So this red portion is actually what's going on over here. The area of this sector is what we would like to find out, because that will be what we call the lateral area. So the area of the sector has a ratio with the full circle. So if I were to draw the full circle, so that lateral area is to the whole circle as the arc length. Now this arc length, this red part right here, is what goes around the circle. And going around the circle is 2 pi r. And the circumference of this circle, circumference is, remember the radius is here, so this will be 2 pi l. So that's how we come up with this ratio. Area of a sector to the whole area of the circle, and that circle has a radius of L, to the arc length, which is going around the circle, and to this whole circle here, which has a radius of R. When we multiply it over and simplify, we're going to get, this is our answer. All the pi's reduce and the 2's reduce, and we get pi r L. Remember, R is the radius of the base, and L is what we call the slant height. The key idea is that the circumference will be the area of the base plus the lateral area, and this is that sector that we found the area of. So let's go ahead and find the surface area of this cone. So the total area is the lateral area plus the base. Remember, the lateral area is pi r L plus pi r squared. So our radius of our base is 4. So we're going to put a 4 here. The slant height is 6. And our radius here is 4. So this will be 24 pi plus 16 pi. And when we add that together, that's going to be 40 pi. And it's area, so it's inches squared. Let's consider a cone in relation to a pyramid. So here's a cone, and inside is a pyramid. And here's a cone, inside is a pyramid. We know the volume of a pyramid. It's 1/3 area of the base times the height. Volume is equal to 1/3 area of the base times the height. As you increase the number of sides of the base, it becomes looking like a circle. So I hope you're not too surprised that the formula for a cone is the same as that of a pyramid. 1/3 area of the base times the height. It's just that in a cone, the base is always a circle. And some people like to write pi r squared instead of the big B. So let's go ahead and figure out the volume of this cone. And so I drew the base right here so that you can see. And remember, the base is a circle, which is pi r squared. So this particular base will be pi times 2.2 squared. And then the height of the cone is 4.5. And we multiply all these together. This is what we're going to get, 7.26 pi. And if you give me an approximation, it'll be 22.81 centimeters cubed. Let's take a look at similar cones. These cones are similar, and the ratios of their heights and their radii are all the same. So we call that the scale factor. Their linear measurements, radius of the small to the radius of the large, is 1:3. And we know the area of the small cone and the volume of the small cone, and we'd like to find the volume and the surface area of the large cone. So I have it all set up. We do have the small area, and we're looking for the large area. And we know that the scale factor is 1/3. So when we square it, we'll get this. And when we cross multiply, we're going to get this. And when we multiply 24 times 9, That'll be 216 pi, and this is going to be feet squared because that is area. For the volume, we know the volume of the small cone, which is 12 pi. We're looking for the volume of the large cone, and we're going to take the scale factor and we're going to cube it, which is 1 over 27. Now we're going to cross multiply, and when we cross multiply, that'll be 324 pi equals the volume of the large, and that'll be in feet cubed. I'd like you to try it. Go ahead and stop the screencast and see what you can do and turn it back on once you're done. And here's the answer. Let's find the volume of a composite solid. So this solid is made up of a cylinder and a cone. And here I draw my base. And remember, the base is a circle, so that's pi r squared. So my base will be pi times 6 squared. And then the height of the cylinder is 5. 1/3, now we'll do the cone, and the base is still the same, pi 6 squared. But the height of the cone is different, it is 4. So this is going to be 36 times 5, which is 180 pi, plus, and then we're going to have 48 pi for the cone, and when we add those together, we're going to get 228 pi meters cubed. I'd like you to try this now. Stop the screencast and see what you can do. And here's the answer.